Great.
Okay, I have a few more slides that we can maybe step through, but I'm finding it's probably going to be valuable to look at the software in more detail itself. Um, but a few of these slides that I want to look at in particular are this idea that was talked about of who needs to be involved. And we talked about this briefly, but this whole idea of the data scientist is a grouping of people that have some computer science skills. So your IT group, um, think of how they're pulling together all of your different data sets and data sources, building for the future that people can have access to that information. You need somebody who's understanding how to apply these tools. They don't have to be a computer programmer. Again, there are ways to apply these tools that you know, this don't require you to be able to code in R or Python. People are going to R or Python simply because universities are teaching in that because it's free. It's not because it's better. It's not because it's validated. It's because it's free. But free for universities is different than free for industry. Free, nothing is free in industry. You're spending time, you're having to try to hire people that know this, you have to try to validate it. So using a lot of these open source tools can be problematic um, for, for commercial entities trying to get into this. So uh, there are many tools out there. Yes, SPM is the one I like and love. It's found in this, but there are many tools you can use to do this. Domain expertise, this is where you need to have business knowledge. You can't expect the IT person and the statistician to determine what you need to analyze and what processes you need to model. You need somebody who has domain expertise or business knowledge expertise um, on, on what you're trying to solve so you can properly define your problem. So if you can find all of this in one person, we like to call that a rainbow-colored unicorn. It's a mysterious beast. They reside right here. But the idea of finding that mythical beast normally doesn't happen. It takes a team of people to get this done. So there are a few other models I mentioned demand earlier, but this CRISP is a data mining model that is used quite a bit. We won't go into this, but these are structured methodologies that can be, you can apply machine learning tools to.
Yeah, but part of the things that maybe our friends here today, they have been used to see the mic because it's so popular in Lean Six Sigma, but maybe Crisp or DM or Zima or however we pronounce it in Spanish, are methodologies they have to become more familiar with them.
And just data mining in general. Um, and some of these concepts, data mining just wasn't fancy enough for many people. So some of that's been renamed into everything from artificial intelligence to machine learning to deep learning. And they all have a little different context and how they're applied. But some of the core data mining concepts, like classification or clustering, um, is really at the roots of all of this.
All right.
So again, collaborative problem. You need to understand the process and the components that are taking place, but these tools really allow this to happen. So the tool we're going to look at today, again, is the whole idea of cards. And I'm just going to put up a whole bunch of words up here. But cards, this is a screenshot of what you'll see in SPM, and we'll talk about this in more examples. But if you think of this as a tree, this is a regression tree and a classification tree. So what it has done is looked at combination of splitting variables to a point of where there is a terminal node the combination of these variables has this result. And again, we will look at this in detail in the software, but the idea is this can be done very quickly. You can determine all of the key drivers and key variables and what will allow you to predict what will happen next. It allows you to save a lot of time. You know, I mentioned logistic regression. Logistic regression is a very powerful tool. It is extremely hard to interpret. A tree gives a visual interpretation, and it allows people to implement these tools, see what is happening, have a model, which is like a regression code, and implement this model into an automated system. I simplified that extremely, but I think it's important that we kind of get into the software and look at that a little bit. Here's my plug just for everything we do. But this is my selfish ad. So, you know, again, if you have questions about these tools, we're talking about predictive modeling and predictive analytics today.
Yes.
But let's go and look at the problem. Are there questions right now that anyone may have?
Vamos a preguntarte, ¿alguna pregunta que tengan los que están conectados web, ustedes, señores, acá? No. Vamos a ver el ejemplo. I think that they want to see some action here with the software.
Okay.
Yeah.
Is everyone still awake?
At least the ones that the ones that are here at the office, yes. I know. I don't know about Alejandro. Alejandro, Silvio, ustedes están despiertos todavía, sí.
Claro, pues estamos.
Perfecto. Dice Paul que si tiene alguna pregunta de momento, Silvia.
So this is, don't let this scare you. This is, now one thing I will say about this tool, when we bought this, it is, Software Predictive Modeler, again, was founded, these tools, CART, TreeNet, Random Forest, were all developed, all of those tools you hear about were developed by the founders of Software Predictive Modeling. So Leroy Wyman, Dr. Stone, these gentlemen out of Stanford developed these tools, developed Software Predictive Modeler. And this is what everybody's trying to recreate now in R and Python, or a lot of these tools.
Hey, Paul, we have a question from, not from this group today, but for the group that we're waiting to join us next Friday.
Okay.
That it is about that comment. The question is it actually true that CARD or these algorithms were developed by the founders of Salford?
Yes, actually they are even registered, copyrighted formulas and trademarks. Yes, so you can, a lot of these founders, I could send that information out to you. They've been cited over hundreds of thousands of times.
Sí.
They are the founders of these tools. Leo Bryman, a lot of his work came out of, so Mars and TreeNet were using radar outputs, and it got a military background, but they were using machine learning to determine off of radar data what a particular vessel would be. Would it be a foreign ship or a commercial ship or a submarine? So using all of this data to determine with great accuracy what the ship would be. So yeah, these guys were solving problems and then they commercialized it.
Yeah, just a little bit, let me just briefly mention that in Spanish. Uno de los puntos importantes es que mucha gente allá afuera, por ejemplo, dice, mira, estamos trabajando con una plataforma en la cual vamos a cargar un algoritmo que alguien nos vendió en R. Los desarrolladores de los algoritmos que van a ver acá, que son de los más populares, CART, Mars, Random Forest, algunos de estos, casi todos ellos son algoritmos que realmente le están comprando a MINITAB para usar, porque la licencia original la tiene MINITAB. Porque los que hicieron ese algoritmo son los señores que fundaron el software, que hicieron el software hace muchos años. Y Paul ahí mencionaba, ¿verdad?, que se ha usado en aplicaciones militares, para radares y un montón de cosas, y luego lo que hicieron fue comercializarlo. Hay que tener mucho cuidado, digamos, porque mucha gente dice, mira, es que voy a, no sé, me dieron un algoritmo y lo vamos a usar. Bueno, ese algoritmo no necesariamente es el original, ¿verdad? Aquí sí estás trabajando, digamos, con el código original del que lo creó.
Con la programación
Entonces,
original.
con la programación original, claro, y eso obviamente asegura pues más calidad en el resultado que vas a obtener. Ok, Paul, go ahead.
Okay, so I'm going to work through an example here, and I'm
Mhm.
simply going to open a data set.
Okay.
The one thing I would like to show, a little bit different than MINITAB, is the amount of different types of data that we can work with.
Entonces son diferentes tipos de datos que puedes jalar, ¿no? Diferentes tipos,
So
formatos de
it
comas,
everything
HTML, de
from
todo
your,
carga.
your access or